Hello, this is Raymond West. I'm the Director of Business and Technology Solutions for VisionMonitor software. In the past few years, through our partner RRE in Norway, VisionMonitor has participated in a European aviation safety project called Prospero. Prospero, short for Proactive Safety Performance for Operations, is a European 7th framework project running from 2012 through 2015 and comprises 14 partner organizations across 7 countries. The consortium includes end users, industry representatives, subject matter experts, and academic partners. The coordinator of the Prospero project is Trinity College, based in Ireland. The EU is working towards 2 specific targets in operational safety by 2020. First, to reduce the accident rate by 80%, and second, to achieve a substantial improvement in the elimination of and recovery from human error. On the 13th of October 2015, the Prospero team conducted the final dissemination event from Trinity College in Dublin in order to review the conclusions of the project and discuss the benefits of the Prospero system and its future use. VisionMonitor participated in this event and helped with the explanation of the technology component of the Prospero solution. Following are some of the video clips from the final dissemination event webcast.
They are often issues that have already been certified as being relatively safe or unproblematic. We were thinking very much about Air France 447 when we were doing the project, but thinking not only about that accident, but other recent major accidents in aviation. I think you will agree that that's a fairly good characterization of them. Right? The implications of this is that we need to understand the sources of variance in normal operations. For those of you who follow the kind of theories in this is what Eric Hollnagel has been advocating in the concept of safety 2. Right? In practice, this means that we have to integrate diverse sources of data and overcome the organizational silos in which such large amounts of data are held in most operational organizations these days. It means getting beyond incident and event data, not just flight data telling you the technical status of the aircraft, but a whole range of other data that tells you about the operation. And we need to be able to use that data to manage risk proactively, preventively, and systematically. There's a problem here. It's just, yeah. Good. Okay. And not only that, we have to look at the process of change itself. And we need to regard that as a source of risk and understand and control the emergent factors in change that make change a very uncertain business. If we look at the current system, the current way in which safety is managed, let's just schematically represent this as gathering reports, gathering operational data, forming risk assessments, making recommendations, and feeding that forward into change. One can see that at a systemic level, there's relatively poor risk assessment due to limited data sources. From risk assessments, there's relatively weak handover of recommendations into implementation. Right? And then even more poor evaluation of system change and poor feedback of current risks into the operation. Thus, I think if we are to move forward into the next generation of safety management, there are 3 critical challenges that we need to face. We need to move beyond analyzing what has gone wrong to analyzing the normal operation in order to better anticipate potential failure. Secondly, we need to be able to implement change and improvement both effectively and reliably. And thirdly, we need to be able to achieve a system view of the safety of the whole air transport system. With these considerations in mind, we put together the Prospero project, and these are the partners. As I say, Trinity College is the coordinator. On the left, we have the operational organizations: Aeroporti di Roma, Alitalia, Athens International Airport, Jefferson, Saga Airport in Pescara, Swedavia, and Thales Avionics. On the right, I'm not going to read them all, is the host of universities, software companies, support companies who are actually making it happen. And our advisory board include members from EASA, Eurocontrol, the Single European Sky Performance Review Board, ENAV, SAS, and Avincis. And many of those are present here this morning. The Prospero concept. The core idea of Prospero is to deliver a new concept of safety management using risk knowledge derived from large and diverse sources of operational data. And to complement that by supporting the management of change through in-depth analysis of change in a collaborative framework that is able to monitor progress of change initiatives and hence understand the risk in change. The idea fundamentally is to close the loop, create a knowledge cycle that feeds back to itself, starting at the top from the acquisition, as I was saying, of diverse data sources about performance, right? The integration of those in a comprehensive data sets, the analysis with sophisticated statistics for large quantities of data, and in-depth qualitative analysis in relation to change. But critically then, feeding that forward into matching patterns of forthcoming operations so that one can begin to predict where potential risks can arise, and using that then to, in a sense, disaggregate the risks and feed forward in a tailored way to those at the operational end what risks they need to manage or potentially might arise in that operation. And out of that, to start the loop again. So hence, it's a knowledge cycle. But actually, there are two loops. And one of the driving ideas of Prospero is to create value for the different stakeholders in the process. Thus, if what I've just described is the knowledge engine at the center there, right, that needs to deliver proactive leverage over system risk performance for those who are responsible for risk and safety management. But for those involved in operations, it needs to directly and tangibly and in a practical way improve their ability to manage their own performance. If we can do both of those things, then that will increase the power of strategic management to improve control over the risks at a strategic level. Critical is also the change loop, and for those responsible for implementing change, for improving the system, we have to radically improve the success rate of change. So those two loops are complementary and need to work together, right, as part of the overall process. What we want to present to you today are essentially 5 complementary case studies demonstrating the core system principles that we've developed in the project. The first one is a data analysis case study around predicting bird strikes by integrating airline and airport data. Second one is around introducing new ideas about sector complexity metrics in air traffic management. third one is about introducing a new de-icing procedure in an airport. The fourth one is about strategic change in a regional airport. And the fifth one is about implementing ACDM. I just want to locate those ones amongst our partners. The first one involves a collaboration between Alitalia and Aeroporti di Roma in sharing data about bird strikes. The second one is based upon research located in the ATM system at Rhodes. The third one is based upon Aeroporti di Roma, a new de-icing procedure, looking at the change process and managing the change process not only in the airport itself, but amongst the airlines, ground handling agents, ATM, and all those involved in that new process. Even more so, the opportunity to work with a small regional airport in Saga, right, made it possible to exert quite a significant change on the overall organization, focusing on the management of performance and risk, but developing also a wide collaboration of all the stakeholders at that airport. And finally, moving to a larger airport, right, implementing aircraft collaborative decision-making in Swedavia at Arlanda Airport. And to emphasize that Arlanda Airport is one of those airports with quite a large number of independent ground operations companies. So it's a real challenge in terms of developing an effective collaboration framework. Hence, I hope you get the picture that Prospero is a network. It's a real system of systems. And in order to explain how it works, I'm going to hand back over to Raymond West of VisionMonitor, who will lead us through these demonstrations. Thanks very much. You have to.
Okay, thank you, Nick. Give me just a moment here to get logged in. Okay, there we go. Thank you, Nick. This is Raymond West from VisionMonitor and RRE, and I am going to be walking you through basically the data collection and centralization component of Prospero. Okay, so I've opened up a web browser here, and we're looking at you know, the main dashboard of the centralization component. So the Prospero system utilizes VisionMonitor software as the data collection, integration, centralization component. Data is automatically collected from various operational systems such as occurrence reports, maintenance systems, and FOQA or FDM data. The data that's collected is combined and analyzed in order to calculate acceptable levels of safety for normal operations at each organization. The system then automatically monitors performance in real time to ensure the operations remain within the defined boundaries, and it alerts for any areas exceeding the defined parameters. So this type of data aggregation and performance monitoring specifically serves to break down information silos, and it transforms the raw data collected into safety information. So the safety information is categorized by the associated operational areas. So on the top here we see the organization of the airline, and below this we see the organization of the airport. So as a safety director, I can log into the Prospero system and review a variety of these indicators providing safety performance measurement of current operations. So for example, I'll click into technical ops here at the airline. And when I do that, I see various parameters, safety performance indicators organized around technical operations. What you're seeing on the graph here is the items on the outer ring are 100%, meaning we have no events or incidents in that area. As it starts to drift down towards the acceptable level of safety, we enter the red zone, and that's when we've exceeded the defined boundaries. So we're seeing basically a line representing the current value and a line representing the value from 30 days ago. And these data points are collected and monitored and created in real time. So what you're seeing is a rolling 30-day indicator that's illustrating current operations. Okay, so let's drill into flight ops here for the airline. Take a look at that one. So again, within flight operations, we see a variety of data. Here's FDM data. We see incident-related data. There's ATM data coming in. So it's a variety of different sets of information. And these data points are really illustrating what's been defined as the highest level of risk in these particular areas. These are the data points that represent risk in flight operations, in other words. The system is collecting more data than this, but these are the ones that are being monitored specifically in flight ops in this scenario. So we see bird strike actually is in the red, and if I scroll down a little, we see there's an alert link for that. I can click that alert link, and it will show me the data set that's actually causing this exceedance. So again, the raw data is actually combined with other data in the system, such as flight cycles, to create a rate, and then we're putting a boundary around that rate that's really designed to monitor the acceptable level of safety. So here we're seeing the bird strikes. We see that some of these are MORs, the occurrence state, the light conditions, weather conditions, and other information regarding the bird strike events as reported by the airline. And finally here at the end, we're seeing humidity, pressure, visibility, wind speed, and so on. Okay. So now if I go back to the home page, we can then come down to the airport metrics. Let's click into flight ops for the airport. So here's various information regarding flight ops at the airport. These are different parameters. So we see, system component failure, power plant or non-power plant, runway incursions, excursions, other information. Here we also see bird strikes, and they've gone into the red as well. So in the same fashion, I can scroll down, click the alert link, and see what data is actually causing this exceedance. And here we see the bird strike data as reported by the airport. So we get dates, the place, the category, the severity, and other information regarding the bird strike. Okay. So again, as I scroll down, I'm seeing other information. Here's flight arrivals, departures. This is bird strikes by severity. We can click into that and get some other information on this. So here we're organizing basically the bird strike as categorized by the incoming data. So 48% of these were near misses. 9.3% of these had no safety effect. We can drill in and see a little more detailed information organized by the severity. So we have lots of different ways of visualizing the collected and aggregated data. We can also look at bird strike correlations. So as we're collecting this information, we can correlate the data together. So we can then combine the data by the airline and the airport together with the flight arrival and departure, so we can see the overall impact of the data coming in. So the Prospero system enables organizations to break down the information silos and continuously analyze the operations in real time. So for a safety director, the real-time safety performance monitoring is an innovation that allows the organization to move really from a reactive to a proactive mode of operation and quickly adapt in a dynamically changing environment. In addition, by enabling the aggregation of data from the different stakeholders, the Prospero system provides the added value of capturing and correlating event documentation and the user's experience from multiple perspectives, like we're seeing with the correlated data from the airline and the airport and its impact on flight departures. So the Prospero data aggregation package improves the safety analysis for change management, operational safety monitoring. We have access into the change management program here. And finally, the aggregated data is also transferred to a safety data analyst. The data analyst then performs a new safety analysis of the bird strike hazard due to the current operational drift. So if I click the send data to the risk pattern, it ends up, the data is transmitted to the safety data analyst at that point. And I'll turn this over now to Massimiliano Zanin, and he will explain the next step in the process.
Okay, thank you, Raymond. So, I'm Massimiliano Zanin from Inaxis, and I will show you how the system can be used by a safety and data analyst. So as a safety analyst, what I want to do is to understand or to test some hypotheses about the appearance and the characteristics of some safety events that in this case are bird strike. So what I want to do is especially to test two different types of hypotheses. The first type is about past events. I want to check whether one characteristic of the bird strike event is related to other. And the second one is, of course, I want to try to forecast future events. That is, I want to be able to understand whether a future flight will be, let's say, may suffer from a bird strike or not. This is very similar to what was previously defined by Nick as the current system analysis and the future risk analysis. So I will start with the first one. Of course, the system has already received the data from the data integration part. We'll go to the descriptive analysis. We'll try to make this bigger so you can see it better. So what I can do here is that I can just try to describe the characteristics of past events that we have in the system as a function of a set of new events, of new characteristics. On the left, I can select a different option. Let's try the first one. So I want to see whether the different events that I have can be classified as potential or real depending on different explanatory operational data that I have on the right side. So I may select, for instance, the month of when the event happened and the light condition. Then here below I can set some options that are not really important at this stage, so I will just set the standard one. I will start the analysis. This is done in real time, so it may take a couple of seconds. And what I obtain is this set of patterns that you can see here. So each row is a different pattern. The columns tell you the improvement of the class, like in this case potential and real, so such that, as you see, the first one, or better, the last one, you have that between months 3 and 5, so essentially it's April, you have an important increase in the probability of having a real bird strike, and then you can check the different patterns depending on the light condition, the month, and so forth. On the right, the last column will give you the confidence that we have in this pattern, that in this case is quite low because the data don't really support the analysis that we have performed. So here you can see whether a pattern is really important for you or just is, let's say, a statistical fluctuation that you have in the data. You can, now that you have this pattern, you can send them to the pattern matching part of Prospero. I will do it now because we will use this pattern in the second part of the presentation. Okay, the pattern has been sent. And of course, this was a descriptive pattern because we have just analyzed past event. And of course, what we would like to do is to be able to predict future events. So what we can do is to go directly to the predictive analysis. It's very similar to the previous one. What we want to try to predict is the appearance of the occurrence of a bird strike. And in this case, let's suppose that we put also the month as before, but in this case, we will use some weather data, so different types of data that have come from the integration part, and we'll check humidity. Once again, we will include all the data, standard representation. We start the analysis. a couple of seconds for the system to calculate this in real time. And here we have the results. So as you can see, we have two patterns. The first one has a low confidence, but the second one is quite important. And we have that when the month is June and the humidity is quite high, we have a quite strong improvement in the probability of having a bird strike. So now we know that a flight that is taking off in June and with a high humidity should be one that probably has a quite high probability of suffering from a bird strike. I will send this pattern to the pattern matching phase, and that's all from my side. So now I will send the control to the pattern matching part, and I will leave the roof to Tim for this part of the presentation.
Thanks, Max. So my name is Timothy Kelly from Prospero Consulting, and I'm responsible for the pattern matching component of the Prospero system. So the Prospero pattern matching application is supported by Corbless Technologies. It manages the creation and near real-time monitoring of complex operational data patterns across airline, airport, and ATM. It can predict safety events and alert operations before the event even happens. The complexities of data aggregation is managed by using a series of big data techniques to improve the quality and performance of near real-time data analysis. A graphical query builder allows the safety analyst design complex risk patterns. Additionally, the system can automatically receive patterns from the Prospero analytics server. So as an example, we can see both descriptive and predictive patterns that have come into the system from the analytics server that Massimiliano recently sent. What a safety analyst can do is he can look at, for example, we can take this predictive pattern and we can see that there is a confidence, there's a severity, and the analyst can adjust or visualize these patterns and potentially add additional information like meta information to build up more complex risk patterns. Once the safety analyst is satisfied and has validated that this is a valid pattern for real-time monitoring, the system once it can be enabled, and the system continuously checks the many data sources for emerging patterns. When patterns have been detected, the application can generate an alert that can be sent to end users. This mechanism greatly simplifies the detection of hidden patterns in the data that would otherwise require great effort from the safety operators. These alerts can be sent to the airline, the airport and ATM operational teams to manage the risk at their level. Now I'm going to hand over to Niels, who will show how an alert is managed in his system once it's sent to him.
While we're handing over the data, the connection, what I'm going to show you now is the final depiction of the data gathered and how it can be utilized by the pilot. Just give it a little second to pull up. What we created at Jefferson is the next generation of the EFB, the electronic flight bag. Our assumption is that the pilots will have PEDs, personal electronic devices, on which they can see the data. We strive to include this final aspect of the Prospero system right inside this to decrease any issues possible due to too many difficult changes in the workflow. So we do include it directly inside the normal setup. So as you can see here, the safety aspect is directly integrated in the normal tile set available to the pilot. So once the pilot receives the information, they can, for example, during their pre-flight briefing or also while they're in flight, have a closer look at the safety aspects and we'll see clear depiction of the most critical areas. As you can see, it's very simple and very easy to see what the affected areas are and how high the risks are. Let's drill deeper into it and look for the pattern that we just received. Please bear with us, we're directly sending this from my iPad, so it's taking a little longer. So here you can see we have an increased risk for bird strike, and we can look closer into the details and see that we have the high risk of bird strike due to the increased humidity. And we of course automatically do the matching of the time of the flight, since we are talking about an integrated system. So in the future it's possible that the risks are distributed not only to those people who already experienced issues before, but also to the more novice pilots, so that the knowledge can be shared and that even the beginners already have some of the experience available that otherwise only the professional pilots after many years of experience might have.
Hello, my name is Morten Idalus. I'm the Safety Director at Norwegian Airline, and I just want to tell you a little bit about our experience from implementing parts of the Prospero system in our company. And as you can see on the screen now, Norwegian has already implemented a similar dashboard to the Prospero dashboard, and we're currently monitoring 100 SPIs in real time. And this has meant a huge change to us as a company. Now we're able to make changes as they appear live. We have a good oversight of our operations, completely different to collecting data and making a monthly report and presenting that to the Safety Review Board. Now all the managers in the company, they have an oversight of how they're performing in real time and can make the necessary changes as they appear. That's actually changed how we do business in Norwegian. Thank you very much.
Thank you for watching these videos. I hope you found them informative. To learn more about VisionMonitor software solutions and the Prospero project, contact a VisionMonitor product specialist today.